Hello everyone! Today's joke of the day is, how excited was the gardener about spring? Stay tuned to find out. Our learning target for today is I can use the converse of the Pythagorean theorem. I know a few Pythagorean triples. Okay? So converse, that kind of means like the opposite. So think about it as the opposite of the Pythagorean theorem. States that if any three positive numbers are a solution to the Pythagorean theorem, then they make a right triangle. Okay, so let's remember that the Pythagorean theorem is a squared plus b squared equals c squared. So if we're given three numbers, and this is true, that the two shorter ones, when you square them, equal the longer one squared, then we know that we have a right triangle. Okay, so we're going to check to see if the following side lengths can make a right triangle. So let's plug these in. We'll take our two smaller ones, 30 squared plus 40 squared, and we're going to see, does that equal 50 squared? Okay, we'll put a little question mark above the equal sign there. Well, we have 30 squared, which is 900, plus 40 squared, which is 1600 or 1600, and 50 squared, we're going to see, does that equal 50 squared, which is 2500. Okay, and if we take 900 plus 1600, that does give us 2500, and which is going to be equal to 2500. Okay, so it checks off. So we can say that yes, this is a right triangle. So if you ever had a triangle with those side lengths, you would know that it would have a right angle in it. Okay, it'd be a right triangle. Let's look at this next example. Here we have 6 squared plus 12 squared, and we're going to see, does that equal 18 squared? Okay, well, we know 6 squared is 36, and 12 squared is 144. And we're going to see, does that equal 18 squared, which is 324. Well, 36 plus 144 gives us 180, which is definitely not equal to 324. So we know that no, this is not a right triangle. Not a right triangle. Okay, so those side lengths would not make a right triangle. There wouldn't be a right angle. All right, now let's look at these side lengths here. If we had 4 squared plus 5 squared, does that equal 6 squared? Okay, well, 4 squared is 16 plus 5 squared, which is 25. Does that equal 36? Well, let's see, 16 plus 25 is equal to 41, which is not equal to 36. So we say no, not a right triangle. All right, let's look at one more example. Here we have 9, 10, and 14. We would take 9 squared plus 10 squared to see, does that equal 14 squared? Well, 9 squared is 81, plus 10 squared, which is 100. Does that equal 14 squared, which is 196? Well, 81 plus 100 is 181. Definitely not equal to 196. So no, this is not a right triangle. Okay, so as you can see, any three numbers put together, not very likely that they would make a right triangle. But we'll look about that in a little bit, at that a little bit more soon. We can also use this to help us solve word problems, okay? So if Alex wants to plant flowers in a triangular plot, she has 3 lengths of plastic edging, and they measure 8 feet, 15 feet, and 17 feet. So we're going to try and determine whether she will be able to create a right triangle for her flowers to be planted in. So let me just draw a diagram right here really quick. We would have 8 feet, 15 feet, and then 17 feet would be our hypotenuse. And we'll see, does that work? Does that make a right triangle? We don't know yet. Okay, so in order to determine that, we're going to use the converse of the Pythagorean theorem. We're going to see if 8 squared plus 15 squared equals 17 squared. Okay, we're going to see if that works. Well, 8 squared is 64 plus 15 squared, which is 225. And we're going to see, does that equal 17 squared, which is 289. Okay, well, let's add them. Let's add 64 plus 225. And that does, in fact, equal 289. So we know that this could make a right triangle. So we can say, yes, Alex can make a plot in the shape of a right triangle. Oops. It's just going to write triangle in the shape of a right triangle. Great. So what a Pythagorean triple, okay, that's a new thing, a new vocab word. And it means a set of three integers that works in the Pythagorean theorem. Okay, that would be a solution to the converse of the Pythagorean theorem. Okay, so for example, if we look back at our first example, 30, 40, and 50, okay, that would be a Pythagorean triple. Okay, those are three integers that work in the Pythagorean theorem. Okay, the four most basic sets of Pythagorean triples are 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. Okay, 3, 4, 5 is the easiest one. We can just double check that right here. That'd be, where I'm still on the highlighter. Give me a second. Okay, that would be 3 squared plus 4 squared equals 5 squared. Okay, well, 9 plus 16 equals 25, which it does. So we'd have 25 equals 25. Okay, so the Pythagorean triple would make a right triangle. Okay, so those are our four most basic sets. And then we also, if you have any scale, if you scale those sets, okay, so multiply all three of them by the same number, that would also make a Pythagorean triple. So for example, if you take 3, 4, 5, multiply each of them by 2, you get the Pythagorean triple 6, 8, and 10. That will work in the Pythagorean theorem. Okay, and there are a few more examples there. Those should be things that should start, you don't have to memorize them, okay, but you should be able to start recognizing, especially like 3, 4, 5 triangles, recognizing that those are going to be right triangles with those side lengths, and that we have those as Pythagorean triples, right? So for today's joke of the day, how excited was the gardener about spring? So excited that he wet his plants. Thanks for watching and have a great day.